motion, and today I am taking the last part of the lesson, that is uniform circular motion. See, we have studied in the beginning only the types of motion, that is uniform motion and non-uniform motion. So at last, in this topic the discussion thing it is the uniform circular motion. Uniform circular motion. See here, this concept we will study by taking into account of four examples. One is the rectangular, the motion of an object along the rectangular track, motion of an object along the hexagonal track, and motion of the object along octagonal track, and motion of the object along the circular track. Through these examples, of motion of the objects along different tracks, so we will come to know what is meant by uniform circular motion. And before going through these illustrations, so one question arises: when the body accelerates. When the body accelerates, in the sense, if the velocity of an object, if the velocity of a body changes uniformly or non-uniformly, then only the body is said to be the accelerating. Whatever it may be the velocity, it may increase or it may decrease, but only the thing is, when the velocity of an object changes through its journey of motion, then only it is said that the body is accelerating. And next question arises: when the velocity changes. The velocity of an object changes in two cases. The first one is when the direction of motion changes. The object has to change its velocity when the direction of its motion changes. And second, when the magnitude of velocity changes, then also the body is said to be accelerating. When the direction of motion of the object, it is needed to change, so then it has to accelerate. That means the velocity has to decrease or decrease. And second one is when the magnitude of the velocity changes. So at that time there is a need of an object to be accelerate. So first let us, after this, so now let us take into the rectangular track of motion of an object. So here when an object is moving along the rectangular track, so here when the object, think the starting point of the motion of the object, it is A, and when the object moved from A and reached B, at the point B it has to change its direction. While changing the direction, it has to change the magnitude of the velocity, and after reaching the point B and after changing the direction, it reaches C. At the point C, again it has to change its direction. While to change the direction, it has to change the magnitude of the velocity in order to balance itself. And next after changing its velocity at the point C, and again while it reaches the point D, and again it has to change its direction. To change its direction, it has to change its magnitude of the velocity in order to balance itself. So here totally its journey from A to B, B to C, and C to D, and back D to A. So it has changed its direction 4 times. 4 times the direction it is changed, and 4 times the velocity it is decreased. That means magnitude of the velocity decreased. And here when we have taken into account of the hexagonal track, the object has to change its direction 6 times. Just because 1, 2, 3, 4, 5, 6 points and 6 corners. 6 times it has to change its direction. And next in the octagonal track, 8 times it has to change its direction. Along with that, the magnitude also magnitude of the velocity, it has to change. So these are all in these rectangular track, hexagonal track and octagonal track, the direction also changed and the magnitude of the velocity also uh, changed. So, but at last, if we taken into account of the circular track, if we have taken into account of the circular track, in this circular track, here the object, it has started its motion, but in this circular track there is no need of changing the direction, no need of the changing the direction, just because here we have not at all finding any corners or the edges as we find in case of the rectangular track, hexagonal track and the octagonal track. Here are no distinct or the corners. Here totally it is a circular path, and object it takes the circular motion. It takes circular motion. That means velocity direction changes, by direction also changes if we have taken into account tangents at each and every point. At each and every point of motion of the object, direction changes. But here, if the direction changes, velocity also changes. But here, the velocity, it changes by equal amounts in equal interval of time, so called the uniform speed. Here, the object is taking uniform speed. Uniform speed. The object along the circular track, here is also the direction of the motion. It changes at each and every point, that we came to know if we have taken the tangents at each and every point. So, but the object, it is moving with uniform speed. That is means the velocity is changing by equal amounts in equal intervals of time. So this is what the circular track. Here the direction changes, magnitude also changes, but it is by the equal amounts. In equal intervals of time. So this is the circular uniform motion. In case of the circular track, the object is moving with uniform speed. So this is this at last, whatever the illustration we have studied, a circular track, the object is moving with uniform speed. So this is nothing but the uniform circular motion. Whatever the fourth illustration that we have studied now, so this is only, it is called as uniform circular motion. What the title now in the today's discussion topic we have taken, the uniform circular motion. So the fourth one is only the uniform circular motion. In case of the uniform circular motion, the object takes the circular track. The object takes its journey through the circular track, and it is moving and it moves with the uniform speed. That means the velocity changes by equal amounts in equal intervals of time. And if the question comes to calculates its velocity, the formula it is to be v is equal to 2πr by t. 2πr by t. 2πr is the formula to calculate the circumference of the circular track or circular path. So that is what the 2πr circumference, and t is the time factor. Velocity is equal to, that is displacement by time taken. So that is the total displacement 2πr by time t. So this is what the formula to calculate whatever the uniform circular motion. Okay, with this discussion we will come to know, so what is whatever the meaning of the uniform circular motion. Students, with this whatever the total lesson completes, and in this lesson main the discussion comes is about the uniform motion, non-uniform motion, equations of the motion, and derivations of the equations of the motion, and the numericals on the equations of the motion, and at last the uniform circular motion. This is also very important, and whatever we discussed today, so on this the 1 mark and 2 mark questions will come in the exams, and you should understand this, understand and remember this uniform circular motion through these four illustrations. Whatever the motion of an object along the rectangular track and the hexagonal track and octagonal track and a circular track. And at last, whatever the fourth illustration we have studied, a circular track. So this is in this circular track, the object has to move with uniform speed, and this is only the nothing but uniform circular motion. In case of the uniform circular motion, the velocity of the object is to be calculated by making use of the formula V is equal to 2 pi r by t, and whatever the unit is same, the SI unit, so that is meter per second. Whatever the SI unit of velocity, that is same applies here in this case also. Okay, and with this the lesson completes, and with this I conclude my today's class.